Hello students, today we are going to discuss about theorem of parallel axis. In the examination, the question is frequently asked on this theorem, or sometimes numericals are asked on this theorem. This theorem is concerning about the moment of inertia of the body. What does this theorem state? The theorem says that the moment of inertia IO of an object about any axis is the sum of its moment of inertia IC about an axis parallel to the given axis and passing through the center of mass and the product of mass of the object and square of the distance between two axes. Mathematically, this theorem can be written as IO is equal to IC plus MH square. When we see the proof of this theorem, then this statement will be clear to you. Now, what is this theorem? It is about moment of inertia of a body, object or body, or it is also called as rigid body. According to this theorem, we can find out moment of inertia of such a body which may be of symmetrical shape about some point, or it should have irregular shape. Even then, we can find the moment of inertia IO of an object about any axis. IO denotes the moment of inertia. O is the point through which the axis of rotation passes. Therefore, the symbol is written as IO. For IC, I denotes the moment of inertia and the axis is passing through the center of mass of that object or the rigid body. Therefore, it is written as IC. So, IC denotes the moment of inertia about an axis passing parallel to the given axis and it is passing through the center of mass of the body. For this, we must know the mass of this rigid body. Let capital M be the mass of this object. This M, capital M, denotes the total mass of the body. Now, what is this H? H is the perpendicular distance between the two axes. In order to simplify this, I have this body. For the time being, consider that this is a solid body. And if we consider only the thin sheet of a metal as a rigid body, then suppose the upper one is a thin sheet of a metal, then for this thin sheet of metal, this C will be the center of mass of the sheet. Hence, one axis that must pass through the center of mass. If we know the moment of inertia about this center of mass for the complete rigid body and the axis of rotation is passing through the center of mass, then we can determine the moment of inertia of the same rigid body or object about the axis passing through any point O. What is the meaning? We can take this O point anywhere, here, anywhere in this body. We can take any point of the body as point O. And now, when we have to find out the moment of inertia about a given axis, we consider that the given body is rotating about that axis. If we have to find out about point C, then the complete body is rotating about that the axis passing through that point. Whenever we have to find out the moment of inertia, what is the formula? It is summation mi ri square I going from 1 to n. If the body consists of a single particle, then we can write mr square as its moment of inertia. Hence, for finding the moment of inertia of the complete rigid body, what we do? We consider a small mass element dm, which is situated at some point such as here at point D. What is speciality of this point D? We have considered that a mass element is situated here. We have considered a small mass dm situated at point D. We call it as mass element dm. Now, if I have to find out the moment of inertia of this mass dm about an axis passing through point O, then when the body rotates about this axis, or if I put this like this, then the body, if it rotates about this point, the axis passing through point O, then the mass dm will revolve along a circle of radius OD. If the axis of rotation passes through point O, then this mass dm naturally will revolve along a circle of radius DO. Therefore, if I have to find out the moment of inertia of only mass dm, then I will write the moment of inertia of that mass dm is equal to dO square into dm. dO square into dm will denote the moment of inertia of this small mass dm about an axis passing through point O. Is it clear? If the axis of rotation now passes through point C, then the body will rotate about point C. We have joined point C and point D. When the body rotates about an axis passing through point C, then this mass dm will rotate through along a circle of radius dc. dc will be radius of the circle when the axis of rotation passes through point C. So for this, if we have to find out the moment of inertia only for mass dm, then it will be dc square dm. For this axis, it will be dc square dm, and for the axis passing through point O, it will be do square dm. For the axis passing through point O, the moment of inertia of mass dm will be do square into dm, because dm is the mass of the element. If the mass of the element is small m, then we will write do square into m. Instead of dm, we may write m if the mass is m of that small element. Now, I have told you that we are considering that the total mass of this rigid body is capital M. And what is h? Now, for simplicity, I am considering here that the axis of rotation for this rigid body passing through point O is perpendicular to the plane, to the sheet. And if I have to use this principle of parallel axis, then I must know the moment of inertia of this rigid body or the object about a parallel axis, passing through point C. As you are observing here, these two axes must be parallel. The axis passing through point O and passing through point C must be parallel to each other in order to apply this theorem of parallel axis. If my axis of rotation passing through point O is like this, then I must know the moment of inertia of the body about an axis passing through point C and which is parallel to the given axis. Remember, these two axes must be parallel to each other, and we should know IC for using this theorem of parallel axis. If one axis passing through point O is like this, then the another axis passing through point C should also be parallel to this. If point O is somewhere here, then this will be the condition. If both are exactly perpendicular, then this will be the condition, like this. So, we have to find moment of inertia of the rigid body about an axis passing through any point O. The point O may be here. This may be the axis of rotation of the body. So, according to the situation, if you change the axis of rotation, the diagram will somewhat change. Now, for simplicity, we are considering that the axis of rotation is perpendicular to the sheet, and here one is passing through point O and another is passing through point C. And now we are going to apply the theorem, or we are going to see what is the exact statement of the theorem. Here again, listen to the statement now. If we know IC, then IO, that is moment of inertia of the body about the axis passing through point O. is given by IO, and IO is equal to IC, that is moment of inertia of the body about a parallel axis passing through center of mass, plus h square. M is the total mass of the body and h square is the square of the distance, rather perpendicular distance between the two axes. So this mathematical statement, if we remember, then we can write down the statement of this theorem of parallel axis in words. How? What is the theorem? It says, it states that the moment of inertia IO of an object about any axis, the point O may be taken anywhere. Here, 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 anywhere. If this is the rigid body, then point O can be taken anywhere in this body. So the axis of rotation is passing through point O. About that axis, we are going to find out moment of inertia. Then it will be equal to IC plus mh square. But what is the condition on IC? IC is the moment of inertia of the body about a parallel axis to the axis passing through point O. And it is passing through center of mass of the body, and that is shown by IC. And plus it is added to mh square. M is the total mass of the body and h is the perpendicular distance between two axes. So this is about the statement of the theorem of parallel axis. Now we are going to find out the proof. We are going to prove this theorem. In order to prove this theorem, we have to find the value of IO, that is moment of inertia of an object about an axis passing through this point O. And by definition of moment of inertia, it is equal to integral dO square dm. And if we have to find out IC, that is moment of inertia of the body about an axis, it is parallel axis rather, passing through center of mass, then it is this dc square into dm. dm is mass of this element. So for proving this theorem, what we have to consider is a mass element dm situated at point D. Then we have to join point O and point D. Similarly, join point C and point D. Also, we have to draw a perpendicular on OC extended. It intersects at point N. So, in this figure, there are two right angled triangles. One is DNO or ODN, and another triangle is DCN or NCD. We may call it also NCD. In these two triangles, we are going to apply Pythagoras theorem for proving this a statement of theorem of parallel axis. In triangle ODN, the square of this hypotenuse, that is DO square, is equal to DN square plus NO square. Now this NO is made up of two lengths, NC and CO. So NO is equal to NC plus CO, and we have taken the square of this bracket. Now it is equal to, means DO square is equal to DN square as it is, plus we have expanded this by using the formula A plus B bracket square is equal to A square plus 2AB plus B square. So NC square plus CO square plus twice NCCO is the expansion of this bracket square. Now there is another triangle which is triangle DNC. In this triangle DNC, DC square is equal to DN square plus NC square. So NC square plus DN square is equal to DC square. Means we can replace this DN square plus NC square by DC square. So we have replaced the sum of the squares as DC square by using Pythagoras theorem, which is applied to this triangle DNC. So here we have written for these two terms DC square plus for OC. What is OC or CO? It is the distance between two parallel axes and it is represented as H. What is H? H is the perpendicular distance between the two axes. So we have replaced CO by H. Hence here we have replaced this CO by H and this CO by again H. Now what we have to do is we have to multiply this equation by dm. Means it will be dO square dm is equal to dC square dm plus H square dm plus twice NCH dm. Now after multiplying by dm, we have to take integration of this equation so as to get integral dO square dm is equal to integral dC square dm plus integral H square dm plus twice H integral NC dm. Now according to the definition of center of mass, this integral NC dm comes out to be 0. What is this NC? What we have done? We have drawn a perpendicular. We have dropped a perpendicular from point D on OC produced. It intersects at point N. So here this CN or NC is is the distance of point D from point C. And according to the definition of center of mass, if we take integral dm, then it is the total mass, and total mass is concentrated at point C. Hence, its coordinate, if we measure the distances from point C, the coordinate of point C will be 0, 0, 0. Therefore, integral of NCdm is equal to 0. Hence, we get the equation IO is equal to IC plus MH square plus 0. This integral NCdm is equal to 0 according to definition of center of mass. Always there is symmetric distribution of mass about the center of mass. Therefore, this integral NCdm is equal to 0. Hence, we get IO is equal to IC plus MH square, which is the statement of this theorem of this parallel axis. Therefore, we arrived at the statement that IO is equal to IC plus MH square. Moment of inertia of an object about any axis passing through point O is the sum of its moment of inertia about a parallel axis passing through center of mass and product of mass of the body and square of the distance between two parallel axes. In this way, we have proved the theorem of parallel axis. Here, integral NCdm is equal to 0. Again, when we have to see the properties of this center of mass, then we know that for the center of mass, some masses are situated to the left, some are situated above the point, some are situated below the point, some are situated to the left of the point. And hence, if we take this distance as negative, this distance as positive, this distance as positive, this distance as negative, and we add all M1 R1 plus M2 R2 plus M3 R3 plus M4 R4, then it comes out to be 0. That is the property of the center of mass. So, according to that, this integral NCdm comes out to be 0. It may be considered as C is the origin, and if this OC is the ON is the x-axis, then this NC is suppose the x-coordinate of center of mass, and the x-coordinate of center of mass is 0. Therefore, this integral comes out to be 0. Therefore, we get the result as IO is equal to IC plus MH square. Thank you.